Thank you guys. Thanks for sticking around today. It is with great honor and pleasure that I get to, be the first speaker at the end of Z-Prime's ETS25. Thanks to Jason, thanks to Chris back there for inviting Sharper Shape to do this. Thank you guys for sticking around. Hope you guys aren't as hungover as I suspect you might be. And today we're going to talk about Clicker. Oh, we don't have the... Okay, there you go. We're going to talk about solving the biggest challenges with asset management. And you'll notice the ... at the end. We're going to have something we fill in at the end. So my name is James Conlin. I'm the Director of Product Management and Customer Success at Sharper Shape. Who are we? We are a small Finnish software company who work with some of the largest IOUs in the US. Recently, we just had a press release showing our 5-year commitment from PG&E to build digital twins with LiDAR imagery and various other kinds of advanced ML technology. They say if you are the smartest person in the room, you're in the wrong room. And I'm very lucky that I've never been in the wrong room for the last 5 years at the company. For a small company, we have a huge tech stack, right? We go all the way from designing hardware that captures this data to creating algorithms and technologies that process this data, things that you guys will be familiar with. Everyone's saying AI this week, AI this, AI that. We're going to talk about real ways that AI is bringing value to this world of remote sensing today. We also offer data feature extraction technologies, right, which we'll get into today. And it gets a little bit abstract, so I've got a lot of information I'm going to run through quickly. And then last of all, we offer, and you'll see how a front-end interface for this kind of data allows you to mine all of the value, right? We're talking about escaping from legacy file systems, huge cloud storage infrastructure that you just don't want to look through 100 million files. We have a ton of data stored. So our data storage is probably closer to 8 petabytes at this point. We've got enough wire miles to wrap all the way around the Earth several times. Tens of millions of images in our platform, thousands of users, and over 1 million sessions a year. So next, we'll talk about what are the biggest challenges. You guys know them far better than we do. From the increased requirements for demand for these energy centers, and these charts you guys show look ridiculous. I mean, data centers that require more than entire municipalities is out of control. Reducing a reduced workforce, problematic supply lines for being able to rebuild this stuff quickly. EV adoption, renewables, right? This urgent need for grid modernization. Really, all of this is about doing more with less. And although I'm going to talk about new challenges, about new technology, actually adopting them are tried and true methodologies. Who here has heard of something like a risk management life cycle? Yeah, right. And as we heard yesterday from Joey, I believe, it really starts with measuring, right? Measuring, you've all seen it. Just please search risk management life cycle. It's what's there. It starts with measuring, finding something that has a problem, planning and strategizing how you'd like to address the challenge, rolling it out, remeasuring. Our customers have a problem. They've never measured this, right? You've built these grids over the last 100 years. You don't know what you have, even though some of you claim you do. You don't know how old they are. You don't know the conditions. You don't know where they are. You don't know about the health of the rights of way from a vegetation standpoint. With increased regulatory requirements, you now, for every asset, every segment, every wire, have to learn about these clearances, right, with a diminished workforce. So let's take a look at how the remote sensing solution at a small scale can augment a typical utility function and really beef up, just level up the way this stuff works. So when you're designing a new circuit, when you understand there's more demand, engineers are going to design plans to build this line. You need a bill of materials from the blueprint. They then, typically, we see them send it to your systems of record, send it to GIS databases, And then a construction vendor will go and actually build these things. You have a prime, they have several vendors that actually build them. And then if you're lucky, as our customers are, who have really high-end utilities, they actually send folks out there to QA/QC the as-builts, and hopefully that data makes its way back into those systems of record. But there is a lag, and sometimes it never happens, right? Certain things that line workers, QEWs can't do are accurately measure all of these things in the field. With remote sensing, we understand, or we create this paradigm, just a really simple addition. Through LiDAR scanning, feature extraction, and then conflation, we're going to update and enrich these systems of record. This is how our customers do it today. So why haven't you done this already if it's so simple? Well, it's really expensive. So people see, over $1,000 per mile is typical for LiDAR, for if you're doing something as advanced as PLS CAD modeling. You also might wait over 6 months to get the results. And how has this changed? Well, it's that key word, right? AI. But what's AI going to do? It's a leap forward in automation for actually getting this data out the door. You've got 3 paths here. First of all, the digital twin can be a capital asset. Our customers are showing that to be true. I think on day 1, someone mentioned, our utility finance groups are happy to speak to other utilities. And I think there are conversations there now where you can, find out how to actually capitalize on this sort of digital twin creation. The next is actually just leaping forward in automation, which means the deliveries come faster. So the vintage of the data is far more useful when it hits your systems of record. It hasn't expired, the vegetation rights of way haven't regrown. It lowers the cost too. And from our perspective, we sell to utility vendors, so it doesn't matter who gets the benefit of this technology, someone's getting it. It's so much quicker and cheaper to get LiDAR data products out of the door now. And next, through a digital twin, you can find more opportunities to extract value. We often see that a LiDAR data collect moves through a pipeline, gets delivered, and then ages. Yesterday, Martina said the exact same thing. Our customers, the utilities I work with have data, but it's just in a file system, getting dusty. This is an example of just completely raw LiDAR data through our US utility-focused ML model. 27 classes are extracted. This is completely automatic, so this is within hours. Points describing every pole are shown, buildings, trees. These models have F1 scores of above 0.99 for many of the classes that are used in this feature extraction. Here's a real overgrown place. If you were in a helicopter, you couldn't even really see the utility lines. Through these new transformative technologies, you can immediately expose the utility connections in here. These are our classes. We released this model last year. We also wrote and released a white paper. So if you are lucky enough to have a data science team, if you have AI engineers, send them here, read the white paper, download our open source data set, train your own ML classification model, and deploy it. Give it to your vendors, let them try it. For us, we consider this the new normal. As soon as LiDAR is calibrated, it's classified within hours. Next, we detect them. So this is not an AI black box. This is a heuristic fitting algorithm. We wrap a cylinder around every utility pole we find in a point cloud data set. Again, this is fully automatic. They are typified by the types of wires. So the different coloration suggests this wire has primary going to it. Next up is modeling. So the same kind of algorithm. We find these conductors, these catenary wires that are wire shapes that are inside of the point cloud. And fully automatic again, we digitize them, and we're able at this point, within hours, depending on the quality of the data, to produce VM results. Yes, you can QA it. Yes, you can refine it further. But I saw last week a customer's data needed no human intervention within hours. So you've got 2 disparate data sets. You have your system of record. You have what we've extracted from LiDAR. Conflation is the process where we bring them together. This is a simple example, but it's real. On the left in red are points that our customer believed they had. On the right is what's really there, and you're performing the typical tasks. deleting records, adding records, fusing records together, saying, I believe this pole moved this direction. We understand there are compliance and union worker considerations to take into account there. So we offer UI for people to actually review this work. So at this point, we've fused together those data sets. We've solved two problems straight away. You don't know what you have. You don't know where they are if you're a utility. And now, finding more opportunities to extract value. We see that paradigm we showed earlier, and we can augment it even further. If we consider this digital twin, a data-driven digital twin, we see it feeds into and from this library of analytic processes, classification, vectorization, just deploying any kind of analytic job. Your GIS folks love things like this. Your data scientists love things like this. It writes to a data storage system. So if you've got PLS CAD, if you work with NERA, your data, your LiDAR can actually just flow right to those places anyway. It's exactly what it was doing before. For construction workers, inspectors, they can visit a platform like this. They can scope out, they can anything they're doing, they can reduce truck rolls, eliminate waste, perform measurements right there from the field. Our customer this year, I don't want to tell you one of them, this year has officially recognized that measurements extracted from LiDAR are higher quality than measurements that people take even with a laser rangefinder in the field. So their engineers are instructed, measure in LiDAR before you go out. You have to collect 150 points of data as a pole loading engineer while you make a site visit. Do 80 of them from LiDAR first. Next, API integrations, right? This is the most important thing. This is the most future forward-looking thing. If you have data scientists, if you work with a consultancy company, and you're storing your data in this kind of system, when you have a need to train a new algorithm, well, an API, you just ship geometry, ship a circuit name, and retrieve all of the images, all of the labeling training data from that API. And this is actually an engine to drive innovation with the big data that utilities now have to cope with. This is a picture of a real digital twin that we've built. Remotely, like I say, engineers, construction workers, if you want to find out, am I compliant? Do my poles on circuit 1, 2, 3 have aviation protection, bird guards, things like that? You don't need to drive anymore. That might be a 2-hour drive. It might be 4 hours in the field, right? Those engineers can now perform things like pole loading calculations. If you're using OCalc, you can go to this digital twin, take the attachment points, actually build a real as-built model. Here you can work out pole lean, guy, slack. This is a dashboard where you can sort your circuits by how many poles are leaning further than the threshold we have, like 10 degrees. How many lines are within 14-foot minimum clearances? And then, of course, UX for inspectors to do things like that, deploying ML models, vision models. Really, for us, it's not about being specific. People come and ask, how accurate are your ML models? Your ML models are commodities. A junior developer can train them in 2 weeks. For us, it's about using remote sensing technologies with a series of tried and tested design patterns. And it's also about making this new paradigm, right, for utilities where they're basing their systems of record on reality, not trying to base reality and your response around a system of record. So, my name is James Conlin. This has been Solving the Biggest Challenges in Asset Management with Digital Twins, a capital asset. Thank you very much.